We have another question from functions. So we are required to find the number of solutions, or rather the number of roots of this function. So the numerator and denominator are, so we have a common factors in both numerator and denominator. I don't know what they are trying by writing it in this form when it can simply be written like this. Because x square minus x plus 3 times e to the power x, this is the common denominator, and the polynomial factor in the numerators was also common, x to the power 2023 plus 2024x plus 2025. We take all of this common factor out. What will we be left with is sin x plus 2. X plus 2025. We want this to be 0. For that, the numerator has to be 0. So either this has to be 0 or this has to be 0. Now clearly sin x plus 2 cannot be 0. It's in fact greater than or equals to 1. So to find the roots of fx, we need to find the roots of x to the power 2023 plus 2024x plus 2025. Now this is a odd degree polynomial. That means this goes to minus infinity as x goes to minus infinity, and this goes to plus infinity as x goes to plus infinity. That is, it crosses the x-axis at least once. So we have that there is at least one root of this polynomial, Now let's say this is gx. So we know that gx equals to 0 has at least a root, a real valued root, that is a root in R. Let's find g prime. G prime x simply is derivative of this plus derivative of this plus derivative of this, which is 0. Now notice that this thing will always be greater than or equals to 0 because it's a even power of x and x is in R. So this whole thing is greater than or equals to 0, and we are adding a positive number to it. That means g prime x is greater than 0, strictly greater than 0, which means gx is an increasing function, strictly increasing function. So we have that there's at least one root, and as it's increasing, it's the only root. So the number of solutions of fx equals to 0 is 1.